Okay. Our next speaker is a very familiar face in the community and a true data enthusiast. Anima Acharya. She's an analytic engineer at Moss and a woman tech maker ambassador. With hands-on experience building and scaling data pipeline, Anima is passionate about simplifying ETL workflow with Google Cloud serverless tools. Today, Anima will show us how to transform raw data into analytics-ready formats using Dataflow and BigQuery, while keeping performance high and infrastructure worries low. Please join me welcoming Anima Acharya. The stage is yours. Okay, yay.
Hi everyone. Thank you, Sital. Thank you to everyone for giving your precious Saturday to JDC Sydney. I'm Anima Acharya. I'm a data engineer at Mosh. That's an AI version of me. That's how AI thinks I look like. I'm a data and analytics engineer at Mosh. Mosh is a health tech company providing service across New Zealand and Australia, and with a mission to provide best possible health outcomes to every Australians. I'm also a Women Tech Maker Ambassador, which is a Google-led tech community to support and empower women in tech. Over the past few years, I have built and modernized multiple data pipelines. Some that ran beautifully, others, well, just taught me patience. And yes, working with data does teach you patience. But before I dive in to through the slides, let me start with a couple of quick questions. How many of you here work with data? Maybe data engineer, analyst? Quite a few, not that much. How many of you here have built the data pipelines if you have worked with the data? Right, 3. Here's the last question and an interesting one. If you could build a pipeline that scales automatically, cost very less, and needs minimum maintenance, how many of you would do that, even if you haven't done that so far? Okay, thank you. That's exactly why we are here. Today, I'll take you through how GCP serverless ecosystem can make the life of a data engineer easier by helping to build easier data pipelines, which scales on itself, scales automatically, requires minimum maintenance and cost low. But before we go that, let's look into why do we need serverless data ecosystem? What's wrong with the traditional systems? Throughout my career, I started my career working with on-prem system. We had 100 lines of Python code, which was used to ingest data, transform data, load data into the system. And once we even doing a hotfix used to be like getting into the server, logging into the server in the dev environment, deploying there first. Once we deploy it in the dev environment, we deploy it in the production environment, all while keeping our finger crossed that nothing breaks. Because we are directly communicating with the server, which over times used to be very infrastructure heavy, requires maintenance overhead, obviously operational complexity, because we can't just write our code, push it to the GitHub and deploy it. We have to actually log into the server and deploy it ourselves manually. That also came with scalability issues, can't do the scalability on our own. And those are the situations which made us realize that the modern data stacks or the serverless data stacks are the way to go. That's where the serverless data engineering comes into the picture. So what exactly is serverless data engineering? Does it mean that we don't need servers at all? That's not true. Serverless data engineering simply means that we don't require the overhead of managing infrastructures ourselves. We can focus on building the data pipeline and work with the data, while the service providers, in this case GCP, will take your overhead of maintaining the infrastructures. You're looking to the scalability and the reliability of your data platform and data infrastructures. So it's more like you rent a truck rather than owning on your own. Rent when you need it, pay for when you are renting it, and then rest of the time you don't have the headache of thinking about where should I park it, how do I manage it, the operational cost and everything. You don't, when it's idle, you don't pay for it. So that's where serverless data engineering comes into the pictures. And these days we can see most companies are getting to the serverless architectures, adopting different cloud service providers. Today we'll go through how we can do data engineering using Google Cloud Platform. So there are, as I mentioned as well, there are few benefits, not few, many benefits of working with the serverless data engineering, one of which is the scalability issues. You can scale your database from few megabytes to petabytes just in few clicks. It also helps you to optimize your cost. Pay only for uses. You don't have to pay when your infrastructure is not running and when it's idle. Just pay when it is running. The idle cost is not required. You can do your development faster, provide faster output to the company and the business. It also simplifies the operations since you don't have to have the overhead of managing servers. The performance, you'll have the reliable performance, built-in retries, and it will be available most of the time. Also, it will be the different data sources that you want to integrate into the platforms. It will provide easy integrations for different APIs and databases. With that, let's get into the GCP. So GCP, Google Cloud ecosystem, Google Cloud has a very strong ecosystem for data engineering. You will find services which ingest data to building a machine learning model. So you'll have everything from every services that you will require to do the batch ingestion, or if you want to do the stream ingestion, you will have services which does that. The ETL engine, BigQuery as a warehouse, you will have services that using which you can orchestrate your pipeline, build dashboards on the pipeline, even BigQuery ML and Vertex AI for your machine learning and AI requirements. So all of these services are very handy to use. Most of them are a few clicks away for you to integrate in your system. But for this session today, we will be going through how you can build a simple data pipeline using GCS, Google Cloud Storage, Google Cloud Dataflow, and Google BigQuery. But first, let's understand what these services do. So Google Cloud Storage is your reliable bucket where you can store all your raw and processed data. Google Dataflow, it's a heart of data processing. It's a fully managed serverless data processing services which allows to build and execute both your batch and streaming data pipelines. With BigQuery, it's a fully managed serverless data warehouse which stores petabytes of data and is completely serverless. So with this tool, let's see how we can build a pipeline connecting all these tools. So let's see how these tools comes into the picture. So the data from the source, whether it be the APIs or databases or just CSV file that you want to load into your databases. So all the data from the data sources, you can load those data to the cloud storage. From cloud storage, you can use Dataflow. So Dataflow is where you build your ETL pipeline. It's an ETL engine. With the Dataflow, you can load your data into the BigQuery, and once you load the data into the BigQuery, you can use those data to build your dashboards, to build your machine learning models, to use it for different use cases that's required for your business. So this is how a simple ETL workflow in GCP looks like. I have a demo prepared for this with the same workflow, which we'll go through in the later slides. So for this demo, I have data sets taken from Transport NSW. It's a monthly Opal tap in and tap off data, which has got the total trips. I'm using Python to ingest data from the API. I'm using GCS for storing the data, Dataflow as an ETL engine, and BigQuery as our destination website. So let's get started. And I have played smart here by recording my demo. Just give me a sec. The technical failure in the last minute. Let me just, luckily I have saved it in the YouTube. Let me see if I can find it. Oops, I don't have the internet connected. I'm so sorry, just give me a minute. Can I have the Wi-Fi connected, please? Wi-Fi? Yeah. Oh yeah, it's not working because I don't have the Wi-Fi connected. I'm so sorry for that.
If you go to the NSWTF events, this one.
Yep.
This type this one. K to capital D is L. Okay. Lowercase L. Did you type the lowercase L? Not one.
Oh, that's lowercase l. Sorry.
That's okay.
Go to the Wi-Fi settings and do it again from there on the bottom of the.
Sorry.
Yep.
Yep. Can I have it again? Yep, it's connected. Thank you.
It's okay. I just want to check your sound also. So if you go here, the next one, just click on that place. Check the sounds on here.
Oh no, I don't have the.
You don't have sounds on
Yeah,
it?
I don't have the sounds there. Thank you. Thank you for the patience, and sorry for the issue. So I thought I played smart, but looks like I didn't. Anyway, so here I have Python scripts. There I have used a API from transport NSW websites, and I have written as a data frame here. So I have another file where I have exported the CSV file to the S3. So once I run this query, this should load the data into our S3 bucket. So in the S3, I have created a bucket called boss strip raw. So we can see that the Python code ran successfully, and now we should have the CSV file in our bucket. So once we have the bucket, now we can use Dataflow to create a pipeline, ETL pipeline, using the data from the cloud storage bucket. So Dataflow provide different methods to build a pipeline. There are different templates available which you can use, but for this one, I'll just create a custom pipeline of my own. I have used job for builder, where I'll give a job name. I'll name it as boss strips, and in the job type you can see you can choose between batch and streaming. I'll just go with the batch ingestion for now. I'll give the source name, that will be the source file name which I have loaded into the S3 cloud storage bucket. So here, among different options, I'll be using CSP from cloud storage, since I'll be using the CSP file that I just ingested using the script. So once I load the CSP file, we can set which delimiter we want to use here. I'll just go with the comma since it's a CSP file, and I have one source ready. We can also add multiple sources if you want to create a pipeline with other sources as well. I'll just keep it as one for now. We can also do some data transformation in the raw data if required. I'll do some basic simple transformations in the data that we have just loaded. So I'll first filter based on the trips. So I'll name the transform as raw boss trip count filters, and you can use different transfer types. I'm using filter using Python, and while doing the data ingestion, I had also saved the file as a CSP file here, which has got ID, year, month, boss reason, card type, trip. So those are the different columns that we have in our CSP file. So the trips has count of the trips, the tap on and tap of trips. So here I will do a simple select statement for greater than 1. I'll just take the data with trips greater than 1, and I'll keep the file as the raw file that I have ingested. So that's the one transformation. We can add multiple. I'll just add one simple transformation here again, where I will be calculating the summary of the trips. So I named it as boss trip summary, and I'll write a SQL transformation here. So from the CSV file that I showed before, I'll select few of the columns, few of the fields that we had in the raw file. Year, month, boss, reason. I did a typo because that's the human working, not the AI, and human makes mistakes. So we have a card type, and I'm doing the sum of all the trips and to get the trips of based on the travels, and I'll group these using year, month, boss, and reason. So this might not be a real world use case scenario. This is for a demo. I'll group it by year, month, boss, reason, and card type. So we have another model ready here with just few lines of SQL codes, and I'll save this one as well. So now let's select where our destination is going to be. I'll be loading the data into the BigQuery. I don't have a BigQuery table created yet, so I'll let the pipeline create the table of its own. I'll select a project for this for this pipeline, which is going to be boss trips pipeline. I'm using NSW boss trip. So I'll create a data set in the BigQuery. So in BigQuery data sets is similar to schema if you have used Snowflake. So I'll name it as boss trips since it's a boss trip data, and then I'll create a data set. Failed again because it does not support dash. So once I create the data set, now I have the data set where I want to save the table. Now we can give the table name, where the destination table name, and we can set the destination pipeline. So in the last step, we can select from which model we want to get our data. So since my last step from the transformation model is boss trip summary, I'll set that as my destination table. So my trip summary is taking a data from another transformation file, and now I will save the destination here and run a job. So running a job is gonna take some time. So this is what I mean by you will need some patience when you work with the data. So while the job is running, we can quickly check the data sets that we created in the BigQuery. So I'll go into the BigQuery, I'll search for BigQuery, and in BigQuery we can see the data sets that we have just created within the data flow. So in the data flow on the right side, we can see the job status. It has says the status as queue, the reason, and all the other informations that is related to the job. We can also see the results, track the results in a table view or graph view. I'll just let the graph view for this one. And in the BigQuery, inside the project that we have selected, we have a data set called boss strips, which is empty for now. So once our job ran successfully, it should load the destination table inside the boss strips table. And here, the running the job is gonna take few 5, 6, 7 minutes. In between, let's recap what we just did. What we did was I used a transport NSW data. It's a boss strip, aggregated boss strip, opal tap on and tap of a boss strip data. So that data, I used a Python script to ingest that data from the web transport websites and loaded it as a CSV file in the cloud storage. In the cloud storage, I already had a bucket created, so I passed that bucket in the Python scripts, loaded the table in the bucket. So from that bucket, I created a data flow job. In the data flow job, I set the job as a batch streaming. So data flow also supports streaming. So if you want to create a streaming pipeline, you can use a PubSub instead of GCS and then create a streaming pipeline in a data flow. I kept it simple, used a batch job, and from that raw data from the cloud data CSV file from the cloud storage, I added 2 transformation layers and did simple transformations within the data flow and then loaded the data into the BigQuery. So once, what next? What after BigQuery? So once we load the data into the BigQuery, we can use other different services. For example, let's say data form. GCS also provides a tool called data form, which you can use for your data modeling. So we can use tools like data form, which we are not going to show in this demo right now, but these would be something that you can use for automating and building a whole full-fledged data pipeline. So you can model your data which are in BigQuery using Cloud Form, and then you build dashboards on top of it using Lucas Studio, which is again another service provided by Google. You can also orchestrate your data pipeline or schedule your data pipeline using Cloud Scheduler, one of the service provided by Google, or Cloud Composer, which is, how many of you have worked with Apache Airflow here? Okay, quite a few. So which is a managed Apache Airflow provided by Google. So you can orchestrate your entire attacks, because for this demo, we have just one data source, one pipeline, one destination table. But in a when you work in a real world, you might have multiple databases, multiple pipelines, which might have dependencies among one another. So you can use Cloud Composer to manage the dependencies and then orchestrate your pipeline, schedule it in the schedule frequency. You don't want to run Python code like I did right now, just go to the terminal and then run it. You might want to run the scripts every hour or every half an hour or in a daily basis. In itself, you don't want to do it manually on your own. So you can orchestrate your pipeline, manage all the codes and dependencies using Cloud Composers and stuff. And also, like from the data that you have modeled in the BigQuery, you can use BigQuery ML or Vertex AI to do machine learning and AI modeling as well. So there are lots of other services as well which you can use on top of GCS, Dataflow, and BigQuery to create your full-fledged data engineering pipeline, which you'll find everything inside the GCP services. Also, like in Dataflow itself, you can see the status is still queued. It will take some time, but here also, instead of batch processing, you can make a real-time pipeline using different other services and stuff as well. So when it's queued, I can take a few questions if you have. Yep. Hello.
No, I slightly missed it. So if I'm a hardcore Airflow developer, as I am, I wouldn't necessarily use this tool because I can do it all in Airflow. This is kind of Google's attempt at Boomi for people who like GUI tools to build their workflows. Is that correct?
I have worked with Airflow, and I have worked where we used to manage Airflow server ourselves, because if you run your own server, you'll have infrastructure overhead of
Well, you can get my Airflow on Marketplace, but Amazon Marketplace, that is. But the question was, if I have Airflow and my infrastructure, well, my pipeline is code, I wouldn't really need this Dataflow tool. That's my question.
It's a convenience, I would say. Like on-prem services and the legacy services, we do things ourselves, but using serverless system means that it will give you more flexibility and more reliability, or more scalability of how you manage and handle a pipeline. You can focus more on building pipelines and working with the data rather than having an overhead of managing your infrastructures. I think there are pros and cons. Like working on serverless does not mean that you will have less flexibility, or you can't do manage things on your own. You still can do things on your own. It depends on how flexible you want to make your pipeline, if that answers your question. Thank you. Yep, so here we can see our first job is running. Our data from the CSV file is in process, so this is still gonna take, I think, few minutes. In between, I can take few questions if you have any more questions. Right, not right now, thank you.
I think everybody is so clear about what you're doing and what you're saying. Yeah.
Yeah, I think that's a good thing.
Yeah.
I'll take it as a good thing. Yeah.
Okay.
Okay. So yeah, my first question is, this pipeline, it has to be triggered manually every time, or there is a way to make it update automatically every time the data the file in the Google Cloud Storage changes, and whether it changes or not, would it load the data on top in the same table, or would it restart the table from scratch?
Yeah, that's what I mentioned about the Cloud Composer and the Cloud Scheduler, the different other services that you can use. So as I mentioned earlier as well, this is something that I created a simple pipeline for the demo purpose. So I'm doing it manually, also to show you how you can build things using these different sources. But when you have to do it in a regular basis, you can obviously use different other tools, like we discussed about Cloud Composer, which manage and orchestrates your pipeline. You can use Cloud Build. If there are so many dependencies, you can go with Cloud Composer. Or if there are single tags like this one, you can use Cloud Scheduler to schedule your job. So this does not have to be manually every time. You can use other services to schedule this and manage this.
Thank you. One more question. This can only be defined in the UI, or is there a way to define this and upload by some kind of JSON or YAML?
Yes, Dataflow also, you can use Apache Bean SDK to code it in either Python, Go, and then version control it, push it into the GitHub, do the deployments from there as well. It does not necessarily has to be from UI.
Thank you.
So thank you for the questions. Coming back to the job, we can see that our job has run successfully. So we have our file loaded. We have both the transformation files run successfully, and then we have our data loaded into our destination table, which is in BigQuery. So if we come to the BigQuery, we should see our newly created table here. Let's check whether we have it or not. So yeah, now we have the destination table in BigQuery, which is called boss trip summary. So within the BigQuery itself, we can preview the data, we can query the data. This is how the trips looks like. I have grouped it based on year, month, boss, reason, and card type. So the total is based on the grouping of that. Another good thing about BigQuery is we can see the lineage here. So I only have one table here, so we don't have any graph here. But if there are more than one tables, we can check the lineage and check the dependencies of how data flow between different models and different services. So that is a simple demo where we use GCP, Dataflow, and BigQuery to build a pipeline. To wrap up, I have few key takeaways. Serverless means focus on data and not infrastructures. We discussed with the questions in between as well. While working with serverless, we get time to focus on data and not have to worry about managing the infrastructures. GCP makes ETL pipeline simple, scalable, and cost efficient. And to wrap up with the last one, start small, iterate, and scale. Don't try to make the entire pipeline at once. Don't try to use Cloud Composer, Cloud Build for CI/CD and everything at once. Start simple, use GCP, Dataflow, BigQuery, or maybe just start with the BigQuery, explore datasets, public datasets available in Google, and then build a simple visualization tools on top of that. And then you can scale as you go, as the requirement become more complex. That's all for today. Thank you so much for listening. I would love to hear about, I hope this session gives you an idea about how you can build a simple pipeline using the GCP services. You can connect me on LinkedIn. I'd love to hear if you have worked with any serverless data engineering pipelines before. With that, I'm open to if there is any remaining questions that we have.
Yeah, we have a question over there.
Thank you for the demo, Amina. So I understand, like, the gentleman mentioned about Apache Airflow, and also the fact that you don't have to manage Airflow if you don't even use Cloud Composer is actually quite a dream, because managing Airflow, different versions of it, is a pain. Now, my question for you at Marsh is that how the data engineering team built all the pipelines, or it's just purely for demo purposes? Because as far as I understand, most of the companies still, not most, a lot of companies still use Airflow as an orchestrator because it existed before a lot of these new tools developed as well. So it could be, Airflow could be a legacy, or do you think that Dataflow could be the future for how data engineering teams build their pipelines?
Good question. Dataflow does not do what Airflow does. Airflow is for orchestrating your pipeline, scheduling the pipeline, and managing the dependencies. Dataflow is the ETL use engine. So you connect data from your database in the Dataflow, and then in the demo itself, we selected where our source database is going to be. If we want to do any transformation, we did that transformation, and then we selected what our destination tables is going to be. So Dataflow is where the data ETL engine, ETL processing come into the picture. It is more for data processing and not for orchestration, whereas Airflow is more for orchestration. Where you have your entire pipeline. You have in the demo itself, we had a Python query, we had a data flow, and if I have to use a Airflow or a Cloud Composer, I would create a pipeline which first runs the Python scripts, and running the Python scripts, it will ingest the CSV file, load the CSV file into the cloud storage, and from there the Airflow job will trigger data flow, and triggering the data flow, the data flow job will run all these steps that we saw in the demo itself. So it will run all those steps, and then it will load the data into the table. So Airflow used as an orchestrator, it's a job in a simple term, let's say it's a job scheduler, which schedules different processes, different steps that we have within a pipeline.
Can I just say, Airflow is definitely not legacy. Version 3.0 just got released last month.
Cool, thank you.
Alrighty, so we have a few more questions for Anima. Well, oh, we have one.
Thanks for the presentation. That was great. So I just have a question around maybe like scaling this out. So when you have a bunch of different engineers who are all creating different data flows, I think it was called data flows. Yeah. How does it manage kind of in a scale sense where everyone can kind of create their own data flow and just run them as they want to? Does it come back to orchestration again? Is that how they're kind of essentially managing those?
Good question. When you use data flow is if you want to ingest data from a new sources, or if you want to add new tables, that is where you have to use that data flow. So managing a different team would also be, there would be specific roles for specific responsibilities for all the team members. And if the team members are maintaining the same pipeline, they obviously don't have to create a new data flow. They can maintain and monitor the existing data flow. If there is a new pipeline that has to be built on top of it, there might be a requirement of building a new data flow. And on the Airflow or the Composer part, once you build a pipeline, you obviously have to schedule for the new pipeline. If you build a new pipeline, you obviously have to create a new job or in Airflow, or maybe update the existing job. It depends on company. There might be some dedicated team for managing Airflow for some companies, whereas in others there might be a same person who does the overall thing. In my case, I have worked in different companies where we do the entire things ourselves. We create a pipeline and then manage it until the update that Airflow job, schedule it in the Airflow. So the entire thing will be done by the one who is responsible for adding that new pipeline in Dataflow. Thank you.
Okay, thank you for, oh, you have follow-up questions?
And just another question on scaling. So how do you kind of reduce the overlap in data and like the calls for data silos and creating overlaps in data? Is there a way you do that? Is that in kind of BigQuery and looking at the data from that perspective, or is there some other way we can look at that to keep costs at
what do you mean by data overlap?
So when you scale a lot, there's going to be a lot of overlap in what data is being ingested. So if you've got files being ingested, there could be one team that doesn't always talk to another team. So there's obviously an overlap there because they're not obviously aware of each other. Yeah.
I think that will be mostly on the communication. In most of the companies I have been with, there are platform teams who manage the overall infrastructures and the data platforms, and there are other teams who use the data from those data platforms and then build their own visualizations or machine learning models on top of that. So most of the cases, the platform team would be responsible for what data goes into the system, but I would also, I think that would be more on how we communicate and how we document. I think the proper documentation will help whether we have already ingested that pipeline in our system or not. And also, on top of that, having a data catalog would also help, because with the data catalog, we can check whether there are those tables which has already been ingested, which are the tables which we already have in our system or not. So maintaining and having a data catalog would help as well.
All right. So we will move on. Thank you so much, Anima, for such an incredible, insightful walkthrough.
Thank you, everyone.